And what that sight scale factor does is it's a scaling factor that allows for us to correct for any error in the turret tracking of the scope. So what this means is this scope is giving us 0.5% more elevation than what we should be receiving. So we're talking about 0.5% of elevation that we're additional that we're receiving there. To give you an idea, working with a few different scope companies and that, with the tolerance of scope manufacturing these days, it's I would say that it's not. You could definitely expect somewhere around 1%, less than 1% of error from a high quality, expensive scope from a renowned manufacturer, okay? And that's very consistent with what I see across a lot of scope manufacturers' lines. Now, if you're using a cheaper scope, I would just say maybe manage your expectations on what the error margin is going to be on the turret tracking of that scope. But if it's consistent, you can account for it, and you can account for it by calculating the sight scale factor. So how would you account for that? All we would do is we'd take our sight scale factor and our raw ballistic solution, right? So if we were to run our raw ballistic solution on the app or on the Kestrel, on the Garmin, whatever ballistic solver you're using, and you were to multiply that by the sight scale factor, that would give you the effective elevation that you need to dial for that corresponding target engagement.